Good morning, everybody. Welcome to Monday. I'll get started in a minute here. If you're not following along with the notes today, make sure you're writing notes down somewhere. There's a lot of notes today, and it's just new stuff, which might not be too complicated for most of you, but there is a lot of stuff. Just kind of like terminology and things to recognize about today. We're going to spend the week, meaning the 3 days, talking about quadratics. So today is all about quadratics. It is mostly notes today. You probably will not be getting, you're not getting an assignment today. Quadratics. I can't spell today. Let's get that closer. There's not going to be a formal assignment today. I'm just going to be giving you notes. Please follow along with the PowerPoint. If you don't have that, please copy things down. I will be adding things on the sketchbook here to supplement that. But we are just going to be discussing quadratics today. And a lot of people get headaches over quadratics. They're really not that difficult. They're just, something new and different that you probably haven't been exposed to. The good part is that the standard form of quadratics, so just like linear equations had a standard form, quadratics are going to have a standard form as well. You probably already have this memorized. This is y equals ax squared plus bx plus c. You've been working with things that look like that all last week and even the week before. It's a trinomial with a degree of 2. So it does look in this form here. However, when it comes to quadratics, a is not allowed to equal 0. And that makes sense because if you put in 0 here for a, then your x squared term becomes 0 and you don't have an x squared term, and therefore it's not a quadratic. It just becomes a line, which is bx plus c, which again, if you replace that b with an m and the c with a b, then you get that mx plus b, which is your slope-intercept form for a line. So this is a quadratic. It looks like this. Some other examples, as long as you have that second degree, you're pretty much it. Your highest degree is your second degree. So other examples might look like f of x equals 5x squared. It might just be that. But it has that second degree, so it is a quadratic. You might have y equals x squared plus 7, and you miss that middle term. So it's still going to be a quadratic because we're looking at for that x squared term or a squared or b whatever. That second degree monomial is what we're looking for here. And then the other one that I threw in the notes was y equals x squared minus x minus 3. All of these are different terms of quadratics. You've seen them mostly in this form here. This here is your standard form. You probably have that memorized. Again, y and f of x are the same thing, so don't get that confused. But that's what they look like when it comes to function, what it looks like on a function. What it looks like on a graph is a little different. They are not lines, they are parabolas. So if I bring up some graph paper here. That way, I think that layer is behind it. There, now it's on top. Here you get parabola shapes. So let's make one right here. That's behind it, is it? Maybe it is. So you get parabola shapes. They look like that. And there's different parts to it. You will note that there is an axis of symmetry here. So you can see that this point here, where's a decent one? I didn't cross any points. Right here, you can see has a buddy on this side here. They are equidistant away from this axis of symmetry here. You can see that this point here is the only one that doesn't really have a buddy because it's on the axis of symmetry. So there's only going to be one point on your axis of symmetry. But if you could imagine folding your parabola in half, it's going to line up with the same thing over here. So this half of the parabola is the same thing as this half here. It's just a reflection over this axis of symmetry, which I have my actual symmetry tool showing the axis there. So if you treat that as a fold line, it's going to go over. And that property is going to be very helpful for graphing, because if you can figure out this point here, then you can figure out this point here. It kind of comes hand in hand. Just going to get rid of this. Right. So we do have what's called an axis of symmetry there. And that's pretty self-explanatory if you know what symmetry is. The next point you need to know, and we're going to draw one this way. My parabola best I can get there, and let's get one over here as well. This one. Next point you need to know, note that each of these have an axis of symmetry here. We'll call this one number 1. Yeah. We'll call this one number 1. And we'll call this one number 2. Our first one here, our axis of symmetry, you can see is at x equals 4. So for number 1, our how do I spell symmetry? There's 2 M's. Is at the line x equals 4. So if x is 4, y is going to be whatever, any value, right? As long as x equals 4, it's there. That's not an actual function because it doesn't pass your vertical line test, but x equals 4 is your line of symmetry there. And for number 2 here, that would be at -4. Is x equals -4. So anything on this vertical line here is your axis of symmetry. And for number 2 and number 1, it's over here. This is your axis of symmetry. And again, that's saying if I folded the parabola in half, it would match up exactly on this side. And if I folded this one in half, it would match up exactly on this side. The next point you need to know is your vertex. So we do have vertex here. Your vertex is going to be your min or your max. You're only going to have one. You're either going to have a min or you're going to have a max. And it's going to depend on which direction your parabola opens. Your min point would be your lowest point, and your max point would be your highest point. Just to put that in a little context. For number 1, your vertex is this point right here. That is the lowest point. So if it opens upwards, you have a min, or a minimum, right? And it is at this point here, which for number 1, that is at 4, 3. And you'll note that your vertex is always going to be on that line of symmetry. So if you know your line of symmetry, you know the x value of your vertex. Number 2, your vertex is going to be this point here. This one opens downwards, so it has a max, right? And its point is -4. Again, if you know your axis of symmetry, you know the first value here, -4. And that's what, 5. Goes up to 5. So given a parabola, you should be able, like the graph of one, if you get a picture of one, you should be able to tell me where your axis of symmetry is, and you should be able to tell me where your vertex is just by looking at it. And again, find your min and your max. That'll be your vertex. And then your axis of symmetry, if you already have your vertex, it's just going to be x equals whatever your x value is. If you're given your axis of symmetry, you can find your vertex fairly easily, or at least you can find your x value fairly easily. Your y value is also pretty easy to find, but we will talk about that later. So here, let's just do a couple more examples from the pictures I got. Let's get a new one. Let's not save that. Can I copy this over? It doesn't like me copying that over. Oh, we'll do it this way. I can't draw on this, but I can point to it. If you're following along in the PowerPoint, which many of you are, looking at these, so this one here, your vertex is going to be down here. I might be able to draw on this, can I? I think that's just a pointer. I think it's just a pointer. But your vertex is here. So your vertex for this graph is going to be 3 on the x, 1 on the y, so 3, 1. And your axis of symmetry is this line right here. So this vertical line at x equals 3. Over here, your axis of symmetry is at -4, because this is going by 2's. So this is at -4, and your vertex is at -4, +4, going up. Shouldn't be too difficult. That stuff's pretty easy. I'm not even giving you much practice on it today. We're just discussing it while I get everything else figured out over here. Yeah, a little bit blurry. Something going to be nicer. Yeah, it's a little nicer. I didn't want that. We'll just take out the bottom there. All right, so let's look at a specific one. What I would like you to do, if you have the ability to do this on graph paper, use graph paper. If not, try to make a coordinate plane the best you can. But let's look at graphing one of these. We're going to graph y equals 1/2 x squared. So when it comes to graphing these things, it's nothing new. It's the same process you've been using to graph anything all year. You're going to make an XY table, and we're going to pick some values just to get an idea of what this is going to look like. I'm going to pick 0, then I'm going to pick a couple positive numbers, and I'm going to pick a couple negative numbers. So again, I'm just kind of picking out different values that I want to plug in, get some points, start plotting it, and see what we get. So here we have the graph of 1/2 x squared. If I plug in 0, then I get 1/2 times 0 squared, and that's going to give me 0. That all cancels out. So I have a point at 0, 0, which is right here. So I'm going to go make that point. If I plug in 1, I get 1 squared, which is 1. 1 times 1/2 is 1/2. So that puts me at 1/2 here. So 1, 1/2 is about right here on my graph. If I plug in 2, 2 squared is 4. 1/2 of 4 is 2. So at 2, I am also at 2. So that's this point here. And if I plug in -1, I get -1 squared, which, just be careful, that's a positive 1. And then 1/2 of 1 is a positive 1/2. So watch your signs. And that's going to be -1 and 1/2 was right there. And then if I plug in, I want that to be a -2. I plug in a -2 to this, I get -2 squared, which is a positive 4, and then 1/2 of 4 gives me a 2. And you should see, because of the way this one is, you should start to see that symmetry happening, and you start to see, hey, this side here is looking a lot like this side here. And there you go. This is not the greatest at drawing lines. Let me see if I can do better than that. Something along those lines. Yeah, that's not much better. Yeah, hopefully you get the idea. These do have arrows. They do go on forever. However, they don't ever go vertical. They will get close to going vertical, but they won't actually be vertical in that sense. And this was a 2. Right, so this was graphing one of them. I am going to graph another one, and I'd like you to graph it as well. And that is, I'm going to do it in a different color here on the same paper. Let's use blue. And here we're going to graph y equals x squared. So again, same deal. We're going to make an XY table for now, because that's the only way you know how to graph these. We're going to pick 0 as a value. We're going to pick 1. We're going to pick 2. We're going to pick -1 and -2. So if I come over here and I plug things in, y equals 0 squared is going to give me 0. Y equals 1 squared is going to give me 1. Y equals 2 squared is going to give me 4. Y equals -1 squared is going to give me +1. Just watch your signs with the negatives. And -2 squared is going to give me +4. So when I go ahead and graph this, this point is shared, and then 1 comma 1, which would be right here, not quite on the other graph because it's supposed to go through that line. 2 comma 4 is up here, and the symmetry is going to be over there. So again, you can use the symmetry to help you out there. And this one's going to look like this. Again, sorry about the drawing. I'm not the greatest with the stylus. But it's going to look like that. The next one I want to graph is going to be in red. Let's get rid of all this. I want to graph y equals 2x squared. So if you look at these graphs here, they're all similar functions except that my a value is changing. So in this one here, my a value equaled 1/2. In the blue one, my a value equals 1. And in the red one, my a value equals 2. So my a value is changing here. And I want to see what effect the a value here has on my graph. But let's do 2x squared here. So y's and x's. Again, 0. I'm going to pick 1. I'm going to pick 2. I'm going to pick -1. I'm going to pick -2. And it's y equals 2 times my x value squared. Pick 0. Everything comes up 0. No surprise there. Pick 1. 1 squared is 1. 1 times 2 is 2. Pick 2. 2 squared is 4. 4 times 2 is 8. Note the exponent's going to make things get pretty big quickly. So -1 squared is 1. 1 times 2 is 2. And again, you're getting that symmetry there. And this one here should be 8. But we can do it just in case. -2 squared gives you 4. 4 times 2 gives you the 8. So yeah, let's plot those points and see what happens with my other one. So 0, 0, they share that. 1 comma 2 is here. 2 comma 8, 1, 2, 8 is up here. And again, the symmetry is going to help you out there when you graph it. 1, 2, 3, 1, 2. I'm sorry, this is 2 comma 8. That's here. And that's here. And you can see this one here is looking like this. And you should note the difference. So the question in the notes was, what do you notice about these curves? Well, you should note that as the a value gets larger, these tend to get steeper on the curve part, or the parabola itself, kind of the width gets smaller. You can see the width between those two is smaller compared to the width between the blue ones and the width between the black ones. So the smaller the a value, the wider the curve. Right? And then if you could imagine if a was 0, it wouldn't be a quadratic, right? If I plugged in for y equals 0x squared, then this is just going to be y equals 0. And that would be this line right here. You can see how it would just flatten that out. It just keeps getting flatter and flatter and flatter and flatter until you get that flat line. A value increases, this goes up and gets skinnier. A value decreases, this goes down and gets flatter. The next thing we want to look at is, what if that a value was negative? I mean, it shouldn't be like as wide as these ones or something, right? Well, if you could imagine these getting flatter and flatter and flatter and flatter, once we get here, what's the next way to do? Well, you just get flatter and flatter and you kind of end up bending downwards. So when we graph the next set, we can see how they go through. And I think if I just delete that layer, it all goes away. And can I move layer 1 up? Yeah, that looks good. So let's look at those graphs. So let's look at graphing y equals -1/2 x squared. Here we have an a value that is less than 0. So when a is less than 0, this is what's going to happen. Here we have a value of -1/2. So again, let's make our xy table. Plug in some values. We get 0, 1, 2, -1, 2. 0 is going to be 0, 1. Again, plug in 1 for it. 1 squared is 1/2. -1/2 times 1 gives you -1/2. 2. 2 squared gives you 4. 4 times a -1/2 gives you a -2. We plug in 1. That gives you a +1. And a +1 times a 1/2 gives you a -1/2. And again, you should be seeing that symmetry happening. And this one here should be -2. But just to check it out, and this is -2. If I plug in -2 here, -2 squared is a +4. A +4 times a -1/2 gives you the -2. So we can go ahead and graph this. We have 0, 0, which is your origin. We have 1 and a -1/2. We have 2 and a -2. And we have the symmetry of that over here. So in this case, our parabola is opening upside down. It's going downward. So here we have a vertex at 0, 0. Here's your vertex. And you'll note that it is going down. So you have a max here as opposed to a min. That's going to be pretty much similar to all the other ones, but we're going to graph them anyways just to check, so we can get this pattern down, and you should be able to look at some of these and be like, oh, I know the shape it's going to make right away just by looking at it. So let's do a blue one where y equals -x squared, right? xy table, 0, 1, 2, -1, -2. Coming in, plugging things in. 0 squared is 0 times 0, 0, right? That's your origin. 1 squared is a +1, then you make it negative. So this is looking at like this. So 1 squared is 1, and then make it negative, you get -1. 2 squared is 4, then make it negative, you get -4. -1 squared is 1, then make it negative, you get -1. -2 squared is 4, then make it negative, you get -4. And then we can plot those. So we have our origin again. We have 1 and -1. And we have 2 and -4. And again, you have your symmetry going with it, which could help you graph pretty easily. And you should see this shape coming out. And you get your parabola going that way. You'll note that comparing your a values here, -1/2 is less than -1, because again we have a -1 here technically. So the smaller the a value, the wider your curve tends to be. The larger your a value, the less wide it is, and these kind of lines get a bit more steeper as you go. So let's look at our last one to graph, just to keep it consistent. We have y equals -2x². So here we want, let's do this in red so we can see the difference. Y equals -2x². Here, -2 is also going to be larger than that, so it should be even skinnier or steeper as we go in. You should be able to see that right away just by looking at it, comparing the two of them. You should be like, okay, this is the widest, this one's in the middle, and this one here is the steepest. So xy table, 0, 0, you get -1. -1² is, I guess we were doing positive words first. +1² is 1 times -2 gives you -2. 2² is 4. 4 times -2 gives you -8. And then -1, you should see the symmetry happening with it. So when we graph this, again, you're getting 0, 0. You're getting 1 and 2. 2 and 8. And the symmetry of it, ending up like that, and you can see how this one here is, oh, that was a horrible line, and that one's not much better, but we're going with it. You can see the wideness of this is even skinnier than the other ones. It fits in between those. And that's how right now you're graphing things. This way of graphing works very well when you don't have any b values or c values. When you get into b values and c values, the graphing is going to be a lot different. But just to sum things up, at the end here, let's file, clear it, let's get rid of our layers. I guess we need one layer. Okay, so just to sum things up for what we've talked about today. So here's a summary of what we discussed. We talked about quadratics. However you spell it, I spell that word wrong all the time. Quadratics in the form of standard form being ax² plus bx plus c. We talked about the axis of symmetry. Which I can't spell either. Symmetry being that fold line, thinking of it as a fold line, where you can fold in half. We talked about our vertex, where you have a max or a min value on your curve, right? The shape of this being a parabola. Always being a parabola, so it's either going to open up or down. We talked about a little bit about graphing them. So graphing just so you get images in your head. When it comes to graphing things, pay attention to your a value. Right? A cannot equal 0 because that means it's a line. If you have a positive a value, then it opens upwards. And therefore you have a min value because the smallest point, and it's going to look like parabola like that. If you have a negative a value, it's going to open down, and you're going to have a max, and it's going to look like that. And I guess we could say the closer to 0 of A means the wider the curve's going to be. So if you have something like negative 1/2 x squared, your curve's going to be fairly wide. Whereas if you have something like 2x squared, your curve's going to be fairly narrow. And that's kind of what we're doing today. Again, it's a lot of just notes. Tomorrow we're going to look a little more in depth and give you some more practice with it, how to better graph these things, because again, this here is our standard form. Our standard form is not just ax squared, which is what we looked at today. So we'll look at graphing these tomorrow, and may give you little tips and tricks on graphing them. But keep in mind the terminology, what we're using, what these look like. They're not too difficult. You will probably be tired of parabolas by the end of this. But yeah, with that, I'm going to end it unless there's any other questions. I don't expect you to do any practice today. We're just taking notes. We'll do some practice on it tomorrow. Hopefully if you understood the notes, you should be able to identify, hey, here's a vertex, here's a line of symmetry. And again, you've been graphing things with XY tables for, well, whole year pretty much. So with that, if there's no questions, I'm going to end it. Have a good day. This is only a 3-day week, so be aware of that. So you have Monday, Tuesday, and Wednesday. You're off Thursday. You're off Friday. Saturday and Sunday you're off because it's the weekend, and you're actually off Monday as well. So keep that in mind. You got a little bit of a break coming up. The next chapter in science, the videos are posted. I will get the assignment list hopefully later today. Will be on there, but the videos are posted. I just have to tweak some things on the assignment list because some assignments we can't do anymore due to the fact that we're not around each other. So I have to tweak that a bit, and I'm still thinking of stuff. So hopefully by the end of the day, that assignment list will be posted. But you have the videos for notes. You can start there. It's going to be on forces. It doesn't look like a lot of videos, but they're long videos. I apologize. Forces, just, there's a lot to talk about with them. So, if there's no other questions, I'm going to end this. If you come up with a question later, feel free to email me. But thanks for your time. Enjoy your day.